Another technology that was developed is something called a magnetometer. Can't get rid of this little guy there. But magnetometer, there we go. What do you think of? Okay, guys, put this together. Magnetometer, what do you think that means? Yes, well done. Okay, the meter tells you it's measuring something, right? And the magnet or magneto means magnetic. So it's a magnetic field. That's exactly what it is. It's a tool that measures the magnetic field. Why would we develop such a thing? What would create a magnetic field? Just guys think about that for a minute. What would actually create a magnetic field? Anyone? Wow. Cole?
I was just saying.
Well, Coleman.
Like an EMP?
Yes, that would definitely create a magnetic field. A bit stronger than what we're looking for.
Okay.
Basically, almost any metal will create a magnetic field, especially any kind of metals that involve iron. If you think about the iron needle in a compass, it basically realigns itself with the magnetic north and south poles. And so what we can do is if you have any kind of substance under the water that's made out of iron, okay, iron is made, forged into steel, so there's that iron base. So again, we're looking for submarines with this magnetometer. Get a much better reading than sonar. We can sort out all the metal versus, is that just a big ridge under the water, or is that a submarine coming at us? And so that's basically what we're looking at here. So anything that has iron in it, we typically are going to have this magnetic field. So they send out the poles, and they start searching for the submarines. And something really interesting happens. When they're all said and done, we're going to talk about those last two bullets here in just a minute. Look at this picture of the Atlantic Ocean. So take a look at that a little closer. We had normal polarity followed by reverse polarity. So here's what we found out. By looking at the magnetometer, we had these alternating series. And not only that, but notice that they are completely symmetrical on both sides of the mid-Atlantic ridge. It's completely the same on both sides. We get these zebra stripes. What's unique about this is that the way that the iron minerals align themselves flips back and forth through time. And what you're looking at is actually a geologic record on Earth's polarity. So what do you think we mean by normal polarity versus reversed polarity? What would be normal polarity?
North is north and south.
Yeah, today's time, right? North is at the North Pole, south is at the South Pole, just like a bar magnet, right? Okay, that would be normal polarity. So then what's reverse polarity? The opposite. All of a sudden the north attraction would be at the south, and the south attraction is at the north. So our magnetic field, remember we talked about that before, the magnetosphere actually rotates itself, and we can see that through the geologic record trapped in the ocean sediments. This is kind of a mind-blowing concept. That our compass that works today didn't always work that way. And you can see we have these regular on and off repeats of normal and normal and reverse polarity. And it happens quite frequently. Now, unfortunately, it hasn't happened within human history, and certainly not within human history of using the compass. So we don't really know what's going to happen. We don't know, how does that affect the Earth as a whole? We don't really know that. What we do know is that it has definitely switched. Now, when we talk about this, how do we get those readings to begin with? That's a big question in itself. How do we get those readings to even show up? Well, if we go back to this second bullet here, or the top bullet, as the magma is coming up at the mid-Atlantic ridge, mid-ocean ridge, the iron that's inside that magma, since the magma is liquid, the iron can swing itself around and get aligned with the magnetic fields. But as soon as that rock cools, what happens to those iron minerals?
They're stuck.
Yeah, they're stuck in place. And so that's how we get these readings. And so as that magma keeps coming up, those minerals are getting frozen in place and we get these repeating cycles here. Now, scientists, and this is something you'll do in a lab tomorrow, each one of these sections has a specific name. And what we can do is understanding the average rate at which the ocean floor is spreading, we can actually figure out how long ago or how frequently the magnetic field changes. Now we were able to predict when the next one might occur. Again, what we don't know is how quickly that occurs. Does it occur, overnight? Does it literally just happen, or is it so, it's gradual? Also, when we start to see the effects of that, we don't really know that. So it's a great question. So again, the two pieces of technology kind of bring it all back together. We talked sonar, and what did we find out from sonar? Yeah, so we figured out that the ocean floor is not flat, right? It has a lot of topography. It's got mountains. It has trenches. What did the magnetometer tell us? Yeah, it shows that the Earth's polarity changes over time. Okay, so those are two really big advances in technology that you need to know about.
I have a question.
Yes.
So what would happen if the, like when the poles change, what exactly does that mean aside from like a compass?
We really don't know.
Where like, could it actually change like the seasons and stuff?
I wouldn't think it would change it. I personally don't think it would change the seasons. Because the seasons is more based on Earth's tilt of the axis. I don't really know what this would change. I don't know. Obviously you'd have some animal species that would probably have issues migrating. Basic scientists believe that a lot, especially the very long traveling birds that tend to migrate, they think that what happens is there's something in their mind or in their brain that allows them to align to the magnetic field and always go in the same place. So that would definitely have an effect on them. We think about our world today with all the technology that we have with GPS and all that, it might cause a little bit of problem, but it wouldn't be anything worse than Y2K, and that was easily fixed. And to me, this is going to be a coding issue where you just tell the GPS to now read that as south instead of north. So I don't think it's going to be that big of a deal. In terms of climate, I don't know how that would affect the climate of the Earth, if it would or not. So, it's one of those things that we just don't know the answer to.